Okay, so now we'll be starting with the numerical solution of ordinary differential equation. Okay, अब बेसिकली इसमें क्या है कि ये दिस इज द फॉर्म ऑफ ए फर्स्ट ऑर्डर डिफरेंशियल इक्वेशन. ठीक है, dy by dx equals to f of x comma y and given that y at x naught is y naught. ठीक है, जो इस टाइप की इक्वेशन होती है उसके सॉल्यूशंस दो टाइप के आते हैं. जो फर्स्ट सॉल्यूशन होता है दैट इज एज अ पावर सीरीज इन एक्स इन विच या फ्रॉम विच द वैल्यूज ऑफ वाई कैन बी फाउंड बाय डायरेक्ट सब्सटीट्यूशन. ठीक है, एंड जो सेकेंड टाइप होता है, जो सेकेंड कैटेगरी होती है, उसमें यू गेट ए सेट ऑफ वैल्यूज ऑफ एक्स एंड वाई. ठीक है, जो पावर सीरीज होती है उसमें मेथड्स, व्हाट मेथड्स आर अवेलेबल? वी हैव पिकार्ड, लेट मी राइट इट डाउन. We have Picard method. Okay, Picard's method. We have Taylor's method. ठीक है, तो इसमें जो आपको मिलता है वो एक पावर सीरीज के फॉर्म में आपको सोल्यूशन मिलता है. फाइन. जो सेकंड कैटेगरी है जिसमें आई एम टॉकिंग अबाउट गेटिंग अ सेट ऑफ वैल्यूज ऑफ एक्स एंड वाई एज अ सोल्यूशन, उसमें आपके मेथड्स आते हैं इसमें यू हैव यूलर, ठीक है, एंड रंगे कुट्टा, which is in your syllabus. This method is in your syllabus basically. Sorry. We have Euler, we have Runge Kutta, we have many methods. I'm just telling you the names. We have Milne, and we have many more. Even we have Adams Bashforth. Okay, so we have these methods in the second category. Uh, in this in this method, the second category, here we are actually calculating the values of y in short steps for equal intervals of x, and this is the reason they are also known as step-by-step methods. Fine. Euler and Runge-Kutta methods are used for evaluating or computing the value of y over a limited range of x values, whereas Milne and Adams Bashforth are used when you have a wider range of x values. Okay. Now the initial condition in this one, the initial condition in this equation, which is specified at the point x naught. So such problems in which all these initial conditions are often given at the initial point only, they are known as initial value problems. But there are problems where second and higher order differential equations are being involved, and in which the conditions may be given at more than one point. So it may be given at two or more points. So such problems are known as boundary value problems. Okay, so anyways, boundary value problems are out of our syllabus. Our focus will be on the initial value problems, and that too on just one method, which is the Runge-Kutta method. Now in Runge-Kutta method, we are going to study uh, two variations of it. See, uh, before Runge-Kutta, you should know what other methods are being involved. We have Picard's method, okay, but these are not in your like they are out of your syllabus. But still, you should know. We have Picard's method. We have Taylor method. Taylor method uh, is having a disadvantage that you have to find derivatives a lot. Okay, there are certain degrees of derivatives available in that, and you have to find them. Fine. Uh, then we have Euler's method. Okay, we have modified Euler's method. Fine. So, and then we have Runge's method, or you should say Runge-Kutta method. Fine. So, in Runge-Kutta method, uh, the best advantage of Runge-Kutta method is that there are no derivatives involved in Runge-Kutta method as compared to Taylor's method. Fine. Now, Runge-Kutta method has two variations. Yeah. Like we'll be studying two parts in this. We have a second order method and we have a fourth order method. ठीक है. अब just give me a second. Okay, so Runge-Kutta method has two वेरिएशंस अवेलेबल. फर्स्ट है सेकेंड ऑर्डर मेथड एंड जो सेकेंड है वो है फोर्थ ऑर्डर मेथड. फाइन. अब जो सेकेंड ऑर्डर मेथड है, लेट्स जस्ट लुक एट हाउ इज इट. फाइन. आई विल बी टेलिंग यू द derivation for the second order method. Fine. And for the fourth order method we will be solving questions. Fine. Second order method के हम questions we will be focusing on that. But still you should know that what are the various popular choices available in the second order method of Runge-Kutta. Fine. अब let's start deriving it. Fine. अब जो हमारी ordinary जो फर्स्ट ऑर्डर डिफरेंशियल इक्वेशन होती है, दैट इज ऑफ द फॉर्म dy बाई डी एक्स इक्वल्स टू जो अभी अभी हमने ऊपर पढ़ा, एफ ऑफ एक्स कॉमा वाई. ठीक है. सो दिस इज आवर फर्स्ट ऑर्डर डिफरेंशियल इक्वेशन. अब जो Runge-Kutta इक्वेशन है वो ये है, विच इज़ कैलकुलेटेड अ स्टेप अहेड, इसलिए i+1 है. ठीक है. तो y ऑफ i+1 इज इक्वल्स टू y ऑफ i प्लस a1 K1. Just give me a second. Okay, so this is the equation. Fine. This is Runge-Kutta equation and this is calculated a step ahead. So y+1 is equals to y of I plus a1 k1 plus a2 k2 into h. ठीक है. Where k1 is f of xi and yi, function at xi and yi, and k2 is function at xi plus p1h and y1 plus q11 k1h. Fine. Now our concern is what are a1, a2, p1 and q11. So what Runge did, they equated this equation, this first equation, to the first three terms of Taylor series, and after equating them he got three equations. What are the three equations? They are a1 plus a2 is equals to 1. This is the first equation. Second is a2 p1 is equals to half, and a2 q11 is equals to half. Fine. So but these are three equations, and you have how many unknowns? You have four unknowns. Okay, 1 2 3 and 4. So now, due to this reason, we have many popular choices available for computing the value of a1, a2, p1 and q11. Okay, so as people took different choices for computing the value of these four unknown variables using three equations, this is the reason we have various methods. So there are popularly three methods available to compute the values. Okay, those three methods are Hume's method, midpoint method, and the third is Ralston's method. Fine. So so the first method is Hume's method. ओके, सो बेसिकली ह्यूम्स मेथड में a2 की जो चॉइस वैल्यू है वो है 1/2. ओके, दे चोज द वैल्यू फॉर a2 एज 1/2. अब जैसे आपने a2 को 1/2 रखा, तो जो आपने ये तीन इक्वेशंस सॉरी जो आपने ये तीन इक्वेशंस निकाली थी, उसमें आप वैल्यू पुट करिए a2 की. फाइन. द मोमेंट यू पुट a2 हियर 1/2, a1 becomes 1/2. Now a2 you put here 1/2, then p1 becomes 1. Similarly you put here and q11 becomes 1. उसके बाद you have to change the main equation, that is y of I plus 1 में आपको a1 a2 की वैल्यू पुट करनी है. सिमिलरली k1 एंड k2 में आपको p1 एंड q11 की वैल्यू पुट करनी है. तो आपकी जो चेंज्ड इक्वेशंस आएंगी वो आएंगी ये. ठीक है. सो दिस इज द फर्स्ट मेथड विच इज ह्यूम्स मेथड. ओके. Now our second method is midpoint method. Okay, so now the second method is midpoint method, and now इधर हमने we have chosen the value of a2 as 1. Now the moment you keep a2 as 1, this equation a1 plus a2 equals to 1 will give the value of this is a1, sorry, this is a1. Okay, this will give the value of a1 as 0. In the second equation, keeping a2 as 1 will give the value of p1 as 1/2. Similarly, in the third equation, q11 will become 1/2. Now the main equation y of I plus 1 will get converted to yi plus k2h. K1 will remain the same, and k2 will be changed to this. Okay. The last method is Ralston's method, in which you are going to choose the value of a2 as 2/3. So this will give the value of a1 as 1/3. Value of p1 will become 3/4, and q11 will also become 3/4. So the equation yi plus 1, the equation of Runge Kutta, will become this. And similarly, k1 will remain unchanged and k2 will be changed to this equation. So these are the three popular methods. We have other choices as well, right? These are the three popular methods, but in which you can keep a2 as 1/2 or 1 or 2/3. So this is Runge Kutta's second order method.